So we have a consumer, which is written in Python. So if you guys are a Python programmer, you can probably easily pick it up. This is a configuration Python file, right? So if you notice here, this is some of the access key and secret key region which you're using, right? So all that stuff is there. And then this is the name of the queue that we are using, right? So in this code, this application, that we are using those attributes. So for example, this is the receiver, right? So the receiver is actually receiving the messages from the queue. In order to receive the message from the queue, you have excuse me, you have to pass a few parameters. For example, you have to provide the access key, you have to provide the secret key, you have to provide a region that the queue is created in, and also the other important thing is to provide the queue name. So if you remember, the queue that we created was the course sync, so that queue needs to be passed in here. So once you have actually passed in all this stuff, then you can go ahead and start, polling your messages from your queue. And once the message comes in, then obviously you can go ahead and start processing it. So this is the other end of your queuing services, which is basically you are responsible for. If I go back to my PowerPoint and show you that diagram real quick. So this end right here, receiver, is basically what I was showing you in the Python, right? So it knows the queue name, the other credentials, properties, and whatnot, and it's just looking for the messages from the bucket, right? So as soon as the message drops on the queue, then basically it just goes and start processing it. Once it's done, then you can go ahead and delete the message. So this is what basically this whole code is. You can see this message is being deleted over here. Okay, so this is one of our sync process, the course synchronization process. Again, we want to make sure that our course stays up to date. So the best way is to actually, whenever there's an update to our course, we drop it on the queue, and then the rest of the stuff is taken care of by our consumer Python file that basically makes sure it picks it up from the course sync queue, process it, and then deletes it at the end. All right, so that's pretty much it for the queuing services. Let's quickly jump over to the SNS service and what is it used for. So Amazon's simple notification services is basically a very important and I think a very useful service along the others, which are also useful. But it allows you to get the notification on events, right? So like I was showing you on the SQS, let's say if something is dropped on the SQS queue, if you want to get notified via email or by SMS message or maybe some HTTPS calls, you can easily get that tied up with your SNS. So SNS can easily pick up that message from there. You subscribe to it, and basically it sends out the message to your to consumer, depending on the subscription model. So if the subscription is HTTP or email, then it would, or SMS, it would actually use that, and provided that you have provided all the properties. You can also trigger an AWS Lambda service. So if something happens, right, you can also trigger a Lambda service. So in my original code, I can easily modify this. Remember, this is like while true, and I'm reading this. I can easily replace this code with my Lambda service, which is kind of the third topic, kind of bleeding into it. But it kind of makes natural transition. So if a message is dropped in a queue, or if you want to process something, what you can do is you can take the message, you can read it, you can drop it on the Lambda service, which is a serverless architecture, and then Lambda basically you upload a code, the same code that I'm doing over here processing, and that gets executed. Advantage of that is basically then you're not constantly doing a while true loop and then reading the queue, but rather you're just basically distributing that responsibility to the Lambda service. The other good advantage of that is basically you pay only when the Lambda service come to live, right? In this particular scenario that we have implemented, that I'm targeting to change this, I'm actually using the server all the time, right? So it's constantly looking for it, and of course you need to make sure that server is up and running all the time. With the Lambda service, with the serverless architecture, you don't have a server that is basically constantly reading the queue, but rather you are actually getting notified by the SNS, right? Saying, hey, a message has dropped. Do you want to process this? And that's when the Amazon Lambda comes to life, and then basically start processing it. Once that processing is done, then and the delete of the message is done, then the Lambda goes dead again, right? So imagine the cost saving that you can have if you're using the Lambda services, again, which is a serverless architecture. I would highly recommend looking into the Lambda service and in combination with the SNS. So, and again, if you're using SQS, then these all three can come together, right? So you have a queue, message drops in the queue, SNS picks it up, notifies this to Lambda service, Lambda does its job, and Lambda goes away. So it becomes a very cost-effective solution if you're using these three services together. Again, I am not using Lambda service at this point, but I do have plans to actually migrate this whole code base from a server-based architecture to a serverless architecture, which would be using the Lambda service. All right, going back to the SNS, so subscribers could be HTTP, HTTPS, email, SMS, and Lambda service. And the way you basically do it is, like as I showed you over here, kind of in transition, that you can create a topic saying, okay, it's an Amazon existing topic instance, stop rule. I mean, there are tons of messages that you can actually you can subscribe to it, and then once the subscription is done, then you would actually get a message to this queuing services. You can also directly access, I believe, if I go here. Oh, sorry, I think they have actually part of the services that you can subscribe to. So, like, for example, if I go to SQS,